Welcome PM1 students to our tutorial on trigonometry. I'm looking today at the June series Pure Maths examinations. This is from June 1 paper. Right, so what have we got here? We've got a tan graph which has been altered, and we have to find out the values of the constants A, B and C. The first one that I would probably look at is B, the shift. Hopefully you can see that this is normally what we would have actually down here, okay, at the origin. So you can see that we've had a horizontal shift of pi over 4, which means that B is pi over 4. Because there's a negative here and we've shifted positively in that direction, so that's that one. Now you can also see that this C here, there's a shift up. So this bit, like I was saying before, should be at the origin, and you can see it's gone up 1, so we can say that C is equal to 1. And how do you find out A? Well, there's a couple of ways of doing this. You could consider what the period for this graph now is. So you can see that the period from here to here it's pi. Sorry, it's pi, which is the normal value. Oh, sorry, I'm getting confused here. So for A, this is a vertical stretch. So I'm not sure the easiest way of doing this. What I would do for this probably is go, well, I know this value here is 0, so I know that A tan now 0 minus B, which I've found to be pi before, plus 1 equals -1, because this is -1 on the scale there. So then I just rearrange this, and I get that A times tan -pi over 4 equals to 2. And then I can just oh, sorry, screaming toddler in the background. So tan pi over 4 gives me -1. So A times -1 equals -2. So that would be -A equals -2, and so A is equal to 2. So that would be how I'd get that one. Right, next I've got to prove this identity. So what are we going to do here? I would probably rewrite the top line as interesting. What could we do here? Well, on the bottom, I could rewrite the bottom as cosine squared theta, because 1 minus sine squared theta. Now that's good, because I can see that this is like 1 minus sine squared theta over cosine squared theta. And so I'm thinking, well, maybe if I could somehow get this to be like cos squared theta over cos squared theta, maybe that's what I need to do here. So I keep that cos squared theta at the bottom. What I could do is turn that 1 into sine squared theta plus cos squared theta. That's one of our identities. And then I've got this minus 2 sine squared theta. Yes, this is looking positive. And so this gives us cos squared theta minus sine squared theta all over cos squared theta, which is what we want, 1 minus tan squared theta. Perfect. Okay, so just remember your the two identities that you've learned, and you're going to apply those most likely. Hence. Okay, well, hence means we need to use what we've just done. So I would say that our result of 1, whoops, shouldn't have done that. Our result of 1 minus tan squared theta ought to be equal to this 2 tan to the power of 4 theta. I'm going to rearrange that. 2 tan to the power of 4 theta plus tan squared theta minus 1 equals to 0. And let's see, I think we can factorize that. I'm going to factorize it like this. I'm going to go 2 tan squared theta in one bracket and the other bracket tan squared theta. I'm going to have a plus 1 here and a minus 1 here. And this will give me tan squared theta equals 1/2 or -1. Now there's no real solutions for that one. So we can just focus on the positive one here. And I guess therefore tan theta is equal to plus or minus the square root of 1/2. And therefore theta is equal to the inverse tan of positive or negative square root of 1/2. And I'm getting from this two values using the calculator, 35.3 degrees and 144.7 degrees. So that's the June 1-1 questions for trigonometry. Moving on to the paper June 1-2. So for this one, I've got to prove an identity. Now let's just have a quick squiz. What are we trying to achieve here? We need a cos x on the bottom. And I'm thinking we're going to just cross multiply, because on the bottom we'll end up with 1 minus sine squared x, which is going to give us cos squared x. And on the top we're going to get a little bit more complicated. We're going to have 1 plus sine x squared minus 1 minus sine x squared. So my next line, I'm going to expand everything on the top, so I'd get 1 plus 2 sine x plus sine squared x minus, and I'm going to put the result of the next one in brackets so I don't stuff it up, 1 minus 2 sine x plus sine squared x. And this is going to be all over cosine squared x, since 1 minus sine squared x is cosine squared x. Easy peasy so far. And then next step is we expand the bracket and simplify the top. So we get 1 minus 1, which is 0. 2 sine x minus 2 sine x, which is 4 sine x. And then sine squared x minus sine squared x, which is 0. And we've got this over this, which is equal to 4 tan x over cos x. And we're done. Because we can take one of the cos x's at the bottom and have that under the sine, which makes it a tan. Okay, so we're going to use that data to solve this next equation. Just checking, the left hand side is exactly the same. So we're going to have 4 tan x over cos x is equal to 8 tan x. Now I'm going to bring everything across to one side. I don't want to lose solutions just in case, so I'm not dividing anything out. So I get this. And then I'm going to factorize out my 4 tan x. So I'll get 2 here, and then minus 1 over cos x here. So that should be my next move. So we've got two options. We can have tan x equals 0, and we can solve for that. X equals the inverse tan of 0. So x equals, now I should have 0. And then the next one is pi, but these are not in the range of the domain here, so we can ignore those ones. The other option is cos x equals 1/2. Now you might be thinking, where the blazes is he getting that from? So we're taking this bit here, right? And we're going 2 minus 1 over cos x equals 0. And so I can go 2 equals 1 over cos x, and then I can rearrange it. 2 cos x equals 1, and therefore cos x equals 1/2. So that's what I did just there. Now if cosine x equals 1/2, we can say that x is equal to the inverse cosine of 1/2, which gives me pi over 3. Yep, pi over 3. And that's in the range, and if we're looking at our cosine graph, and we've got one there, you can see there's going to be none other in the range. So we're done. Okay, so that's the June 1-2 questions, fairly simple. June 1-3. Okay, show that the equation blah can be written as blah. Okay. So probably what I'm going to do first is I am going to rewrite my tan x as sine x over cos x plus sine x. And then that's all going to be over, again, sine x over cos x minus sine x. Now what we can do at this point is factorize out our sines. And then we're going to have 1 over cos x plus 1. And over here we're going to have sine x into 1 over cos x minus 1. We can cancel out our sines at this point. And I'm going to rewrite that top line as 1 plus cos x over cos x, because that's how we can write that, because 1 over cosine x is 1 over cosine x, and cosine x over cosine x is 1. And we'll do the same thing with the bottom, so it'll be 1 minus cosine x over cosine x. And so we can cancel those out, and so we're left with I should have probably had k's on the right hand side here. So you get 1 plus cos x over 1 minus cos x equals k, which is what we wanted to prove. That was very easy. What are we doing now? Hence express cosine x in terms of k. Okay, so I'm going to go 1 plus cos x equals k minus k cos x. I'm going to move the k cos x over to here, and I'm going to move the 1 across the other side, so then I can factorize out my cos x. So I get 1 plus k, k minus 1, and then I've now got cos x. By dividing that 1 plus k bracket across, I've got cos x in terms of k. Well, that was pretty easy really, wasn't it? Okay, next one. Hence solve the equation. Right, so hence, what the heck? Okay, fine. So what we can do now, they're wanting us to solve this here, and when it equals 4. But we have expressed that as this, okay? We did that in the first question. And now we know that k is 4, right? Because we've been told it here. And therefore we can say what cosine equals in terms of k. So it's actually very simple. It's a matter of just going cos x equals k, which is now 4 minus 1, over 1 plus 4. So cos x equals 3 over 5. And therefore x is equal to the inverse cosine of 3/5. Now, inverse cosine of 3 over 5. So I'm getting 0.927. Now, our range is between minus pi and positive pi. Now, here's pi, and so minus pi is going to be out here. Okay, so if I've got 0.927, which is, where is my 0.927, say, somewhere here. Right, there's going to be another one out here, which should be symmetrical, so that should be my 2 ounces. Well, that'll do for the trigonometry. We've done all of the June trig questions for the Pure Maths 1 papers. I hope that's been helpful to you. I hope you get the general gist of what I've been doing here. Alright, God bless, take care.